What do you expect to get from a space telescope that cost a cool $10 billion and made the whole world hold its breath during the launch and deployment? The James Webb Telescope is gradually settling into its new home, and it's already sending back pictures of the universe. The latest pictures are stunning and shock the entire space industry. What is in the latest picture delivered by the James Webb Space Telescope, and why is everybody going gaga over it? Fewer space telescopes captured the world's attention like the James Webb Space Telescope. Fewer telescopes also got as delayed as the JWST, and no telescope costs as much. The JWST is a collaboration between NASA, the European Space Agency, and the Canadian Space Agency. The JWST supplants the Hubble Space Telescope, which has not only provided stunning images, but has also been vital in providing scientific knowledge about our universe and its origins. But because astronomers and scientists need better instruments to help us understand the universe, the JWST was conceived. After development and testing work that spanned decades and came close to being cancelled by the government, the JWST launched on Christmas Day last year. That was no ordinary launch, as the telescope had to be folded to fit on the launch vehicle. Its primary mirror, 2.7 times larger in diameter and about 6 times larger in surface, had to be broken into 18 parts. There were no second chances for the development team because the JWST was meant for a destination so far away that there was no hope of sending astronauts to fix it or even refuel it. However, things went well, and the JWST arrived at its home about a month later. The signature heat shields, which also had to be folded, unfurled with no incident. The launch was so smooth that the JWST saved enough fuel to almost double its expected lifespan. The telescope will stop working when the fuel on board runs out, unless the engineers come up with a method to refuel it 1 million miles away. Since its arrival, NASA scientists and engineers have been busy setting it up. This is a complex process that will take months because many parts of the telescope have to be configured and calibrated, and they have to be tested at each step. The tests involve taking images. The first image from the JWST was an 18-star mosaic taken in February. The image, which you can see on the screen, is a single bright star in the constellation Ursa Major, known as HD 84406. The star was seen in 18 different positions because JWST's mirror segments were still in the process of being aligned. This seemingly chaotic capture was a result of JWST's unaligned mirror segments reflecting light back into the telescope's instruments. It was a vital part of preparing Webb for eventually taking stunning images of the universe. Weeks later, the JWST took another picture of the same star, and the difference was clear. NASA completed focusing the James Webb Space Telescope's primary mirror on the 11th of March. The result was a precision that surpassed all expectations. You can see the stunning image of star 2MASS J17554042 plus 651277, which NASA released on the 16th of March 2022. The image was significant because it proved that NASA scientists had managed to correctly align each of JWST's 18 primary mirror segments, which gives the telescope the honeycomb mirror design. The JWST has taken another step out of numerous steps towards beginning its exploration of the cosmos. This was no mean feat because it meant the 18 separate images were aligned into a single point of light, focused to within an accuracy of 50 nanometers. That is a fraction of the wavelengths of infrared light that it will observe in. While there is a star in focus chosen because of the ease of identification, the image contains many galaxies in the background. By the end of April, NASA was confident the alignment of the JWST was complete. The telescope was certified to be capable of capturing crisp, well-focused images with each of its 4 powerful onboard science instruments. Upon completing the 7th and final stage of telescope alignment, the team decided the JWST could move forward into its next and final series of preparations, known as Science Instrument Commissioning. This process would take about 2 months before the JWST is thrown open to scientific operations in the summer. NASA released more images to the public which captured the telescope's full field of view. Lee Feinberg, the optical telescope element manager for the JWST, claimed that the images showed what people from different backgrounds working together could achieve. Meanwhile, the JWST continued to wow the engineering team with its optical performance. The telescope's mirrors are now directing fully focused light collected from space down into each instrument, and each instrument is successfully capturing images with the light being delivered to them. The image quality delivered to all instruments is diffraction limited. This term means the fineness of detail that can be seen is as good as physically possible given the size of the telescope, so NASA engineers don't have to make any substantial changes to the primary mirror segments. What you are seeing now are engineering images of sharply focused stars in the field of view of each instrument. They demonstrate one thing, that the telescope is fully aligned and in focus. For this test, the JWST was pointed at a part of the Large Magellanic Cloud, a small satellite galaxy of the Milky Way. The view provides a dense field of hundreds of thousands of stars across all the observatory's sensors. You might notice the difference in sizes and the unusual positions of the images. What the pictures show is the relative arrangement of each of Webb's instruments in the telescope's focal plane, as they each point at a slightly offset part of the sky relative to one another. The telescope's three imaging instruments include the NIRCam, NIRISS, and MIRI. The fourth, NIRSpec, is actually a spectrograph, but it can take images for collaborations and target acquisition. The dark regions you can see in parts of the NIRSpec data are due to the structure of its micro-shutter array, which has several 100,000 controllable shutters that can be opened or shut to select which light is sent into the spectrograph. There is also the fine guidance sensor, which tracks guide stars to train the observatory accurately and precisely. The two sensors are not generally meant for scientific imaging, but they can take collaboration images, which will appear like those in this image. The image data is used to assess image sharpness and also to precisely measure and calibrate subtle image distortions and alignments between sensors. With the alignment completed, NASA turned its attention to commissioning the science instrument on board. These include detectors equipped with unique lenses, masks, filters, and customized equipment. The test will involve pointing to different areas in the sky where the total amount of solar radiation hitting the observatory will vary to confirm thermal stability when changing targets. Meanwhile, NASA released another series of images captured by the JWST. They are the most stunning ever from the new telescope. The image again shows the Large Magellanic Cloud, captured using the JWST's mid-infrared instrument. This instrument specializes in mid-infrared imaging. It displays the MIRI test image at 7.7 microns, debuting a section of the Large Magellanic Cloud as never seen before. The LMC is actually a small satellite galaxy to our own Milky Way, but houses dense star fields, thus serving as an apt field in which to test Webb's next-gen capabilities. The image compares a zoomed-in section of the MIRI image placed beside an earlier image of the same target region imaged by NASA's Spitzer space telescope using infrared array camera. Spitzer is no longer active, but it was one of the first to supply high-resolution images of the universe in both near and mid-infrared. It is not surprising that the JWST is producing images that humble the Spitzer. Each of the 18 mirror segments on the new telescope is bigger than the single one on Spitzer. It is clear that the JWST will use its primary mirror compounded by its enhanced detectors to provide scientists a much sharper view of the infrared sky, promising potential breakthroughs in deep space astronomy. For example, the image produced by JWST shows the emission from polycyclic aromatic hydrocarbons, or molecules of carbon and hydrogen that play an important role in the thermal balance and chemistry of interstellar gas. When the JWST is ready to begin scientific observations, studies such as these with MIRI will help astronomers discover new facts about the births of stars and protoplanetary systems. The JWST might be ready for work by July, based on the amount of progress recorded. What will the Space Telescope target first officially? Scientists are keeping that one a secret. Let's hear what you think of the James Webb Space Telescope in the comments section below.